And if you want to let your mind wander, if you want to let your brain wander through neural networks so your mind can wander to more distant associations, you're going to have to shut off the noradrenaline release. I mean, if you think about when you're really focused and nothing else can get into your mind, if someone comes in and says something to you, go away. That's the impact of noradrenaline. So
One of my favorite things to talk about is the brain. In this conversation with Dr. Robert Stickgold, who co-authored this book, When Brains Dream, we are talking about the brain. We're talking about what happens in the brain when we dream, what happens during REM sleep, and what happens during EMDR. So Dr. Stickgold didn't just co-author this book, but he wrote these articles about what happens in the brain when we do EMDR. In this conversation we are talking about REM sleep, we're talking about dreams, and we are talking about what happens in the brain when we do EMDR. This is a fascinating conversation with a world expert, Dr. Robert Stickgold. And I want to welcome our speaker for today. So, Dr. Robert Stickgold, welcome to the Art and Science of EMDR, and thank you so much for joining us.
I'm delighted to be here.
Yeah. So, Bob, we are talking about your book that you co-authored, When Brains Dream, and I wanted to start by asking about what a lot of people would consider a dream job that you had. So, if you can talk about what you've done at Harvard and maybe even before Harvard, what did you do? What was your work?
Well, I came to this field by one of the most circuitous routes possible, I think. My doctoral thesis was on bacterial cell wall. Sorry, my undergraduate thesis was bacterial cell wall biosynthesis, and my PhD thesis it was on DNA replication in bacteria. So I started way over in biochemistry, and then walked a long path to end up at Harvard as a postdoctoral fellow doing neurophysiology, and then spent a few years at UMass Medical Center as an assistant professor, and then came back to Harvard, where I originally joined the lab of Alan Hobson before I became independent, and have been doing sleep and dream research since the mid 90s.
Wow. Yeah, and you mentioned Alan Hobson a few times in the book. So I wanted to ask you, I guess it's a big question, and we can spend the next 6 hours talking about it, but why do we dream?
We dream because it is a clever, evolved mechanism that allows the brain to sort of wander through our associative networks of memories and look for memories that might have been overlooked in our waking lives that are actually relevant to our current concerns. And we dream because the only way the brain has of sort of imagining things, of creating scenarios, of narratives, of watching a story unfold is to do it in our conscious mind. And so if we need to look at these stories to understand whether or not these related memories are useful, then we have to dream about them. We can't do it in the background.
Yeah. Um, so reading your book, I learned that the function of dreaming is not related to us remembering our dreams. I'm wondering why are we, I say we, I mean therapists, are so obsessed about our clients remembering our dreams? Why are we why is that so important? Why do you
Well,
think it's important?
if our model of dreaming, Tony Zadra, my co-author, and myself, if our model is right, then the function of dreams is to isolate and identify um, past memories that are relevant to our current concerns. And what a therapist does is takes our current concerns, and older ones that the current concerns are connected to, but takes them and tries to help the client explicate them, to come to understand them. And if those dreams are trying to do the same thing, I mean, our model is called Next Up, which is an acronym for Network Exploration to Understand Possibilities. Then the dreaming brain is in essence doing the same job, if you will, as a therapist does, which is to say, to help the client explore their past, to understand their present and the future. And so it's like, they're getting some cheap help.
Yeah. I know we talked about a little bit before we started recording about Freud, and I was wondering if it's a Freudian idea, that idea that we have to have our clients write down and remember. And you mentioned that or interpreting dreams and remembering dreams and assigning significance to dreams started way, way, way before Freud.
Oh yeah, it goes back. I mean, it probably goes back as far as spoken language existed. We know it goes back as far as written language existed. The stories of Gilgamesh, which are from about 5,000 BC, the earliest known written stories, have multiple examples of Gilgamesh getting involved with his dreams, and his dreams being involved with messages from the gods. But the Oracle of Delphi, I mean, in Greek times, would interpret your dreams. There's something about dreams that grabs us. One of the worst things about being a dream researcher is that when I tell someone I'm a dreams researcher, the next 8 words out of their mind, without exception, are, "Oh, I had the most amazing dream." And then they tell me this really boring dream. But it's important to them. And it's important to them because their brain, when they recall the dream, is reactivating those associations. There's something about REM sleep that might bias the brain towards really leaning in on the dreams being meaningful and important. So I don't think it's right. Freud is the person who medicalized dreaming, who sort of saw it as a clinical issue as opposed to just a wonderful thing.
Yeah, so I don't know if it'll make you feel better, but you're saying that as a dream researcher, people tell you their dream. For us as therapists, a lot of times when we meet new people, they tell us about their, psychiatric diagnosis, histories of trauma, and medications they're taking. So I don't know if it makes you
Yeah,
feel better.
that's right.
That's just, the nature of our jobs. You mentioned
Yes.
REM sleep, and I wanted to talk about REM sleep versus dream sleep. It seems like there's some kind of confusion even among researchers. So, can you talk about REM sleep and dream sleep, and what do they have in common, and what do they not have in common?
Yes. This is Alan Hobson's fault. Back in the late 70s, he published and co-authored a couple of papers where he introduced his activation synthesis model of dreaming. And it was entirely based on the neurology of REM sleep. And so for Hobson's theory, there's only dreaming in REM sleep. And he knew that wasn't true, but for the sake of his model, he sort of defaulted to that. And he started talking about REM sleep and dream sleep interchangeably. We probably dream more in non-REM sleep in a given night than we do in REM sleep. But our most intense, our most emotional, our most visually vivid and bizarre dreams tend to occur during REM sleep. So to back up a second, REM sleep is REM sleep, rapid eye movement sleep. And it turns out that while we sleep, our brain cycles through a number of different states in a 90-minute cycle. And at the end of each of these 90-minute cycles, the brain enters REM sleep, this rapid eye movement sleep, where the EEG starts looking almost as if you're awake. And again, where our dreaming is most intense. It's neurochemically different because in REM sleep, serotonin release is shut off, norepinephrine release is shut off, acetylcholine release is increased, so the whole chemical milieu of the brain changes, and even the functional connectivity of the brain changes, so that the brain is more likely to access remote associations in REM sleep than normally well-connected associations.
So I wanted to ask you about, you mentioned a few neurochemicals in the brain, serotonin and noradrenaline. Can you explain the functions of why does that happen, and what are the functions of, for example, serotonin? What happens when during REM sleep there's really pretty much no release of serotonin? Why does that happen?
Well, mechanistically, we don't know. We don't know what it is about the entry into REM sleep that shuts those neurons down. But it's basically, that's going to be a hypothalamic projections that are controlling REM and non-REM cycle, and they're projecting to these places in the brainstem where norepinephrine and serotonin are released from and shutting down those neurons. Functionally, we really can only guess. Noradrenaline is very good for focusing the brain. If you have focused attention, noradrenaline levels will be high. And if you want to let your mind wander, if you want to let your brain wander through neural networks so your mind can wander to more distant associations, you're going to have to shut off the noradrenaline release. I mean, if you think about when you're really focused and nothing else can get into your mind, if someone comes in and says something to you, go away. That's the impact of noradrenaline. So the shut off of that might be involved in letting the brain wander further. It might also keep you in a more relaxed state, the brain in a more deactivated state, deactivated from an emotional point of view. And the serotonin is a funny question. We're not sure what shutting it off does, but I have a personal suspicion, and that's really all I dare say about it, that what it's doing when you shut off the serotonin is it's making thoughts and associations feel to the individual more important and more meaningful. Because the only time you get that sort of feeling of things being really important, like you do when you're dreaming, the only other time I know of that it happens is when people take LSD. And LSD will also shut off serotonin release in parts of the brain. So it might be that this is the gimmick the brain uses to help dreaming serve its function. So let me cycle back to that next up model again for a minute. What next up proposes is that when you're sleeping and when you're dreaming, your brain is identifying in non-REM sleep, not so weakly related associations. In REM sleep, really weakly associated memories in neural networks that your current concerns are connected to just very weakly. And it wants to ask the question, are these useful? And to do that, what it does is it takes those remote memories and it builds them into a narrative. It creates a story. It imagines a scenario. It dreams. It dreams. And then what the brain does is it watches the emotional responses of the dreamer in the dream to see if their emotions are activated. And the brain's algorithm, its rule is that if activating this remote memory and integrating it into a dream causes emotions, then in some ways it's important. It's potentially useful. And that's the signal to the brain strengthen the connections between its memories of this ongoing concern and this older, possibly even childhood memory. And I think what serotonin shutdown does is it makes it more likely to be identified as important. I tell the story of my parents. My mother, if I told her something I did at work, she would always get excited and say, "Oh, Bobby, that's wonderful," even though she probably didn't understand it at all. Whereas my father would say, "That doesn't seem very useful," even though he didn't understand it either. Those are just sort of their personalities. And so
Yeah.
when you go into REM sleep and you're activating these weak associations, I want my mother kibitzing, not my father. So
Yeah.
that shut off of serotonin can increase the likelihood that the brain will identify this as an important connection. And then if I happen to wake up out of that dream and the serotonin is still shut off and my brain is still biased in that way, I go, wow, wow. And then I want to tell Debbie my dream, my wife Debbie, and I tell her my dream, and she says whatever and goes back to sleep because it's not interesting to her because her serotonin levels aren't toned down.
Yeah. Um, it's interesting you mentioned your parents. So you say in the book that during REM sleep, the brain activity increases in large portions of the limbic system, and at the same time, the activity decreases in the dorsolateral prefrontal cortex. So would you say that you can say that your mom represents the limbic system versus your dad represents the dorsolateral prefrontal cortex?
One could say that. I mean, it's a bit of a chicken and egg going on here, but the activation of the limbic system during REM sleep clearly will drive the brain towards having emotion in its dreams. So that's probably what's driving the emotional intensity of our dreams. And at the same time, dorsolateral prefrontal cortex, what a mouthful, is normally involved in executive control, in impulse control, in logical thinking, and in rational thinking. Um, and if all of those are getting shut off, then the brain sort of is just letting that dream go on its own without kibitzing. There's no one saying, that's not logical. Wait, that couldn't happen. Wait, I don't think that's a good thing for you to be doing. All of these sort of voices that are normally, the person behind you who's always telling you what you're doing wrong or right, all of those internal brain mechanisms are being shut off. And again, this just lets the brain really follow its own paths without judgment. And another thing that happens is that output from the hippocampus is shut off. And the hippocampus is where all of our episodic memories of actual events from the day, for example, are stored. And so that output to the cortex, to the front parts of the brain, are shut off. So when we have a dream, we are literally unable to remember the waking event that might have actually caused it.
Yeah.
So our frontal cortex is our prefrontal cortex. Our brain is really just allowed to run from the bottom up. It's letting these memories be reactivated from the past and if I can quote somebody else, it says to the brain and the dream mechanism, just go for it. Just go
Yeah,
with it.
I was yeah, resisting the urge to switch to, to that, to talking about EMDR, but I wanted to ask you before we start talking about EMDR, because you also wrote two articles about the suggested mechanisms of EMDR. I wanted to ask you about mood improvement. You say in the book that when dreams succeed in their overnight modulation of emotions, there's a pre to post sleep improvement in the dreamer's mood. So what does that tell us about the function of dreams or sleep in general?
Well, so clearly one of the functions of sleep is to allow the brain to reset It's the emotional compass, if you will. Now, if you're a depressed person or an anxious person, it doesn't mean that they're going to be feeling perfectly healthy in the morning, because when it resets your compass, it might be to depression or anxiety. But if there were events of your day that drove your emotions higher, a night of sleep and even a nap, I think, there's data for that too, will sort of reset it back to maybe where it was the morning before. But Rosalind Cartwright, way back, it might even have been in the 1970s, did studies with recently divorced women, and showed that depending on how they dreamt about that divorce or their ex-spouse, back then ex-husband, in their dreams, predicted whether that divorce led to depression, and predicted how they felt in the morning. So if they remember, this is the caveat of this is when people remember their dreams, because it's the only way we have access to their content. But when people remember their dreams, if they're good dreams and if they're about important subjects, then they tend to feel better in the morning. So in addition to sort of, I think, just a sort of a passive drift over the night towards back towards normality, I think dreams that effectively process emotional memories will also help regulate people. And, my mother always used to tell me, don't worry, Bobby, things will look better in the morning. And I hate to think that my whole career has just been proving my mother right time after time. But in this case, I think she's absolutely right.
Yeah, yeah. If you get good sleep, right?
Yeah, and certainly if you don't, anybody who has a partner knows that if someone is not getting good sleep, you don't want to be around them. They become really unpleasant.
Yes.
It's the kid who doesn't have her nap who
Yeah.
becomes a terror in the afternoon.
Yeah. Bob, I wanted to ask you. You mentioned the next step model, and that's the model that's your hypothesis. I'm wondering if you can talk more about that model, and in particular about weak associations, because I think that's where things kind of start to merge into what we do in EMDR. Kind of makes sense in terms of the mechanisms of action.
Sure. So it turns out that our dreams are actually qualitatively different in the different stages of sleep. When we dream in non-REM sleep, um, people usually define the sources of elements in their dreams as recent events, episodic memory. So I describe it by saying if someone wakes up out of a non-REM dream and they were dreaming about flying saucers, if I asked them, why were you dreaming about flying saucers, they would be likely to say, oh, I had pizza for dinner last night. I'm sure that's where the flying saucer came from. If they wake up from REM sleep and tell me a dream about flying saucers, and I ask them what they think that's about, they'd be more likely to say, oh, I just love pizza. I've loved pizza my whole life. And so it becomes this sort of global semantic memory of things that go way back. And, they want to tell me about 100 times they've had pizza over the last 10 years. So dreams in REM sleep tend to be more semantically related to our memories. They tend to be related to our more distantly associated memories, and more emotional memories, it feels like too.
I
So I
wanted
might have forgotten the actual question that you asked, though. So I don't want to. I wasn't trying to avoid it.
No, 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 no. I was asking about the model next up and
Yes,
weak associations.
right. So it turns out that we spend about 16 hours a day with what's known as the default mode network of the brain activated. This is the As its name implies, this is the default mode of the brain. When the brain isn't doing anything else, when the brain isn't paying attention to something, when the brain doesn't have something it needs to do, it settles into this default mode. And even as we're talking, the people who are logged in and listening and paying attention, every once in a while their minds wander to something else. Maybe they're thinking about something I said and trying to understand it better, or maybe they're wondering, did I leave the stove on? Or maybe they're thinking about dinner tonight, what they have to cook, or maybe they're thinking about something that happened yesterday. This mind wandering happens all the time, even when we imagine that we're really paying attention. And the reason we think that it does that is because that's the brilliance of being human. It turns out that it's really easy, relatively, to perceive things and to memorize them. Way back, I had an Apple II Plus computer with 48K of memory. That's 48,000 bytes as opposed to billions of bytes now. And that thing could project onto the screen anything it saw on a camera. It can play anything that it had coming in on an audio track. It had no problem perceiving things, and it could memorize them. It could store that information. But it wasn't until the last 2 or 3 years that computers have started to be able to understand or to tell us what those images, what those memories mean,
Mm-hmm.
what the meaning is, what the significance is, what the use is of those perceptions and those memories. That's a much, much harder task. And so it turns out that as we go through our lives, every minute that we're not forced to pay attention to something because of what we're doing, because of what we want to be doing, even some of the time while we're doing those things, the brain is shifting into a mode where it's trying to process that stored information and understand it. And it takes 8 hours, ideally, out of each of our days to set aside to do just that. Sleeping is primarily about memory processing because for every 2 hours we spend awake taking in new information, the brain literally has to disconnect from the outside world for an hour to try to figure out what it means. Which of this information that I've just encoded in the last day do I want to keep? Which do I want to forget? What memories should I connect these? What older memories should I connect these new memories to? Should I connect this to podcasts? Should I connect this to trauma? Should I connect this to sleep? Should I connect this to memory? How do I want to file this memory away so that it will be available to me in appropriate circumstances tomorrow? Which parts of this memory do I want to keep? I don't want to keep all of his stupid little stories. There are a few key points that I want to remember, but how do I decide which ones to keep and which to forget? We do all of that while we're sleeping, and we weaken the strength of our emotional response to those memories when they're recalled the next day by processing them while we sleep. So all of this memory processing is going on while we sleep, and it's a lot of work.
Yeah. Yeah, you mentioned in the book a theory about why we have such an epidemic of insomnia, and it is also related to the default mode network. I'm wondering if you can. That was one of our interesting discussions, and I think that a lot of our clients and some of us are experiencing some of the effects of uh, modern day. Well, you can talk about maybe why do you think why do you think there's so much insomnia in relation to the DMN?
Yes. So one thing you have to know about is the sleep onset period, which is called the hypnagogic period, which just means sleep starting in Greek, but it sounds so much more sophisticated if you say the Greek version. Um, as we lie in bed at night, what happens? We lie there, we close our eyes, And all these memories from the day arise. And we sort of see them flitter through our mind. And what the brain is doing in that period is it's actually replaying these memories from the day while we're awake, or just in the first literally 2 or 3 minutes of sleep, and identifying which of those are incomplete. That would be my terminology. Which of those things that happened in the day aren't we done with? So in the simple version, it's thinking about things we were doing, a paper I was working on that I didn't get finished, things that I have to do tomorrow that I was supposed to be preparing for that I'm not really prepared for enough, things that people said to me that I'm not quite sure I understand, that I really need to think about more. And it's seeing these things sort of riffle through our minds and our brains, and it's tagging them. It's literally putting a little tag on it to say, okay, this is a waking memory that I want to work on more while I'm asleep. Normally, these memories just wander through our minds and then we drift off to sleep. Sometimes, though, they're upsetting memories and they trigger an adrenergic response. That's not how it's supposed to work at sleep onset. At sleep onset, you're supposed to say, oh, right. And my boss told me if I didn't get my work together better, I was going to get fired. I'm going to have to do something about that. And then literally just drift on to the next topic. When those reactivated memories from the day actually trigger an adrenergic response, which is what they would do if they had been reactivated an hour earlier, what happens is you have insomnia. You can't fall asleep during an adrenaline surge. You got to lie there in bed for 10 or 15 minutes while your liver burns up all that adrenaline and gets it out of your system. And then you can start drifting off to sleep again, but the same thing might happen again. So these anxieties invoked by your brain in response to these memories is probably the leading cause of insomnia. Now, I told you that normally in the day, we're doing some of that work already. We're going back with our default mode network and we're reactivating these memories and we're looking at them and we're starting to tag them probably during the day for later so that when we get to sleep onset, it's not such a big job. But we are not letting our brains do that anymore. It's a very strange thing, but people don't want to be alone with their thoughts anymore. Look at these guys here.
Mm-hmm.
AirPods. AirPods might be the biggest cause of insomnia in our culture because walk down the street in a city and look and see how many people aren't on their phone or don't have AirPods in, who are literally alone with their thoughts. I told my son Adam, it used to be when we walked to school, we were just alone with our thoughts. And his response was, that's really creepy. I think I'd put AirPods in for sure and put some music on.
Yeah.
We're not comfortable with our thoughts anymore. And as a result, we lose a lot of that pre-sleep processing time. That sort of, first of all, helps us resolve some of the more straightforward issues, the ones that don't require our brain to go into these more distant and weak associations. I mean, where we can just think about things and process them more the way you might do it in a therapy session. And we're stuck then as we're falling asleep, trying to cram all of this work that should have been going on during our mind wandering and daydreaming during the day and squeeze that all into the 5 minutes that we're trying to fall asleep, and it doesn't work.
Yeah. Yeah, I think one example of what you said about not wanting to be with our thoughts, if you stop at a red light and you look to your left, you look to your right, everybody's always on their phone, which is that's a scary thought. But if you really look, even when you're on the highway, if you look at what people do, a lot of times you see people on meds, which is even more scary. Um, Bob, I wanted to ask you about PTSD, post traumatic stress disorder, or another way to ask this, about PTSD is what happens when next step malfunctions?
So one of the things we clarified way back in 2000, the year 2000, was that when we dream, we don't replay memories. We did this study where we had people record their dreams, underline the parts where they think they know what happened in their life to cause that particular element, and then explain it. And it was never a replay of memories, never a replay of what happened in waking. It was all some sort of metaphorical transformation to that, of that. And it looks like less than 1% of the dream elements for which people can identify a waking source. Only 1% look like they might actually be replaying a memory. The exception to the rule is PTSD, where patients, clients with PTSD on a daily basis, on a nightly basis, if you will replay in their dreams these traumatic memories, the memories that are the basis of their PTSD. And think I think what that replay is telling us is that the brain is not, that next up is failing. That what the brain is supposed to be doing is accessing in the background that traumatic memory and then dream about associated memories. So if the trauma event that caused the PTSD is a car accident, maybe it'll play memories about plane crashes, or maybe it'll play memories about being on bumper cars in an amusement park. It'll be pulling up other related memories to see if they might be useful to the person. In waking, when they wake up, even if they don't remember the dream, these associations will have been strengthened. That can be useful to them. And the fact that they're just replaying this trauma memory over and over in a near veridical form means that the brain, while we're sleeping, is not being able to identify these related memories. That lets the person process that memory in waking and say, oh, okay, that happened, but these other things happened too, and they didn't destroy my life. And I've got past those, I can get past this. I mean, all of that grows out of discovering these associative links. And I think it's probably most likely because even when we sleep, PTSD sufferers can't shut off their adrenaline release. If you look at the rate at which the metabolites, actually, if you want to get technical, of adrenaline are appearing in a person's urine, normally these levels drop dramatically across sleep. So normally when you fall asleep, all that adrenaline is happening during the day to the events of the day. It just gets broken down and it's gone. And so our adrenaline levels are low. Even in non-REM sleep, they're much lower than during waking. Patients with PTSD, their adrenaline levels stay high or even go higher while they're sleeping. And that might literally mean that now the connection between the hippocampus and the cortex is such that the brain can actually access those memories and replay them while it's dreaming. And then it can't find these weakly related associative memories because the adrenaline levels are so high.
Yeah. Okay, so Bob, we have a few more minutes, and I wanted to talk a little bit about EMDR and ask you about the article that you wrote many years ago. And it's a suggested mechanism of action. In the article, you said that you're not trying to prove how EMDR works, but to provide a reasonable explanation. And I'm wondering if you think that one day we will have over the past few decades we've been, you know, we've been having advanced technology, and we having better way to look into the brain and what's happening in real time. And I'm wondering if you think that one day we will have an actual answer to what is happening in the brain during EMDR. We will have not a proposed mechanism of action, but a proven mechanism of action. I think all of us want you to say yes.
So the good news is yes. The answer is yes. The bad news is the time frame for it, and I just don't know what that is. There are techniques that can be employed now with these big, fast computers and functional magnetic resonance imaging, brain scanning, that really let us see better in the brain what's going on, even while we're dreaming. So we can, a lab in Japan has done this where they do this fMRI imaging while a subject is sleeping, and then look at the pattern of activity in the brain on a very, very fine and sophisticated levels, literally looking at these 1 millimeter or 2 millimeter cubes of brain tissue all through the brain. And they can say, oh, look, that person's brain activity means that they're imagining a woman's face. They're seeing a woman. And then they wake the person up and say, what were you dreaming? And they say, oh, I was dreaming I was in a grocery store and I was having an argument with this woman who was the checkout lady and da 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 da. So they can actually now get a hint, and it's not much more than that, of the visual imagery that happens during dreams. So can we, across an EMDR session, during the kind of voxel-based imaging with fMRI before a session, after a session, present the same images to the person or the same voices or the same recorded script to the person before and after, and literally ask what's changed in the activation of the brain, in the patterns of activation in the brain as a consequence of that EMDR session. And if we had millions and millions and millions of dollars and lots of time to do it, we could say, okay, and what does the reduction in SUDS tell us about those changes? Do we see different changes in what you might call a more successful EMDR session? Or what happens if you just do a standard therapy session without EMDR? Can we see changes? And maybe even eventually we could find a way to do brain imaging during an EMDR session. It's tricky because you can't be talking or your brain moves too much, but come up with an altered protocol for EMDR where, you're not, in fact, responding after a set of eye movements, and ask, what does the brain activity look like during an eye movement set? And not just at that gross level, being able to see the regions of the brain that controls your eyeballs being activated during the eye movements. But again, with this sort of voxel-based analysis of brain activity, try to pick up more sophisticated images of what's happening in the brain. Now, on one level, I have to tell you, I don't know how much more this tells us about what's going on. At some level, we know what's going on in the brain because the person's getting upset. So we know the amygdala is getting activated, and we know that, medial orbital frontal cortex is trying to get that amygdala activation toned down under control. And we know, that visual images are coming up and maybe auditory memories are coming up because we can have the client report to us afterwards. But I suspect there would also be surprises. There would be new things discovered that might be more generic and tell us more about actually what EMDR is doing. It's both exciting and frustrating because I have no idea what it is that we will be finding.
Okay, I want to invite our community members to turn their cameras on in a minute and ask you some questions. I know a lot of our community members read your book throughout the month, but first I want to thank you, Robert Stickle. Thank you so much for your time and
It's
for a
my
wonderful
pleasure.
book.